All right, so today we're diving into something truly spectacular. And let me tell you, the pictures alone are, phew, incredible.
Yeah, no kidding.
We're talking glowing blue waves, folks.
Nature's light show, right?
Exactly. And we've got some fascinating articles here about a massive bioluminescent algal bloom off the coast of San Diego back in 2020. Have you ever seen anything like this?
Oh, absolutely, yeah. It's not every day you see the ocean lit up with, like, an electric blue glow. Honestly, it's a spectacle. Best described as magical, I think.
Yeah, the pictures look otherworldly.
They really do, but what's truly fascinating is that it's all thanks to some very, very tiny organisms.
Okay, so let's unpack this a bit. The articles mention dinoflagellates.
Right, dinoflagellates.
So first things first, what exactly are these little creatures?
Dinoflagellates, well, they're single-celled organisms, practically invisible to the naked eye, and they live in marine environments.
Okay, got it.
Think of them like fireflies of the ocean,
Well,
basically.
that's a good way to put it.
They use a chemical reaction within their bodies to produce light. It's a process called bioluminescence.
Oh, so each wave crash is like, what, billions of tiny fireflies lighting up at once?
It's pretty amazing, yeah.
Well, why blue, though? Why not green or yellow like fireflies?
That's a great question. And, it all comes down to the specific chemical reaction happening inside these dinoflagellates
Okay.
and how that light interacts with the surrounding water molecules.
Makes sense.
The blue wavelength actually travels the furthest in water,
Oh, interesting.
which is why bioluminescence often manifests as this, beautiful blue or blue-green glow.
So it's like nature's own underwater light show designed for maximum visibility.
Exactly.
Speaking of light shows, the 2020 event in San Diego seemed particularly impressive. The articles mentioned something about, like, the perfect storm of conditions.
Oh, yeah. It was a combination of factors. Heavy rainfall that year, for one, and that led to incredibly nutrient-rich water.
So plenty of food for our little dinoflagellate friends.
Yeah, think of it as like an all-you-can-eat buffet for them. A specific species called Lingulidinium polyedrum thrived in this environment.
Lingulodinium polyedrum.
Yeah,
I'll try to remember that one.
you and me both, right?
It's just amazing how such a tiny thing can cause such a massive, like, visual impact.
It really is.
But this brings to mind something else we often hear about, red tides, which don't sound nearly as appealing. Is there a connection there?
You're spot on. It's actually, well, it's fascinating. The very same organism that's responsible for the, magical blue glow can also create what's known as red tide during the day.
Wait, seriously? The same organism?
One and the same.
Tell me more about this.
It all comes down to how light interacts with the pigments inside these dinoflagellates, you see.
Okay.
So during the day, their high concentration causes the water to take on this reddish-brown hue.
So they're like tiny chameleons of the sea, transforming the ocean's color day and night.
That's a great way to put it.
Okay, so we've gone from these tiny glowing organisms to a tale of two colors in the ocean, a beautiful blue at night and a, well, not so appealing red during the day. But it makes you really appreciate the power of nature.
Absolutely.
Are there any other, like, larger implications to these massive algal blooms besides this visual spectacle?
Oh, absolutely. And you're right to bring it up. You see, these blooms actually play a really significant role in the ocean's ecosystem.
Okay, cool.
And, well, it's not always a positive one, unfortunately.
Right.
So while they can provide a food source for some marine life, the rapid growth and decomposition of these organisms can lead to oxygen depletion in the water.
That doesn't sound good.
No, it's not, and it can harm other marine species like, fish and invertebrates.
Right.
Yeah, it's kind of a delicate balance, really, like everything else in the natural world, I guess.
Well said.
Right.
So something as beautiful and magical as a glowing wave can also have these, potentially negative consequences, huh?
Yeah. It's a good reminder that even the most captivating natural phenomena are often more complex than they might appear at first glance.
This deep dive has been incredible, from the science of bioluminescence to the ecological impact of algal blooms, I don't know about you, but I'm left feeling a sense of wonder and a thirst to learn even more about, the hidden world of the ocean. What stands out most to you from all this?
That's a good question. I think for me, it's realizing that, bioluminescence isn't just a spectacle. For many creatures, it's a crucial adaptation.
Oh, how so?
While scientists believe that dinoflagellates, for example, might actually use their glow to startle predators, or even, get this, attract bigger predators to eat the ones that are trying to eat them.
Wow, that's incredible. Talk about a bright idea.
Yeah, it's amazing.
Really makes you think about all the other, incredible adaptations happening in the natural world that we might not even be aware of.
Exactly. There's a whole universe of wonders waiting to be discovered, even in our own backyards, or in this case, off our coasts.
That's a great point. And for you listening, the next time you're near the ocean, especially at night, take a moment to really observe the water. You never know what hidden beauty or, what ingenious survival tactic might be glowing just beneath the surface.
That's right. Always pay attention.
Well, on that note, thanks for taking this deep dive with us.
Glad to be here.
Until next time.
See ya.